Okay, this is the 2013 Level 3 electricity paper, question 2, using an inductor to produce a spark. First question was a capacitor to produce a spark, but here we go. In the circuit below, for a spark to be produced between the gap AB, which is just there, the voltage across AB must be greater than 1.20 times 10 to the 2 volts, which is 120 volts, so that's good to bear in mind because it's easier to think in terms of 120 than using that. Okay, switch 1 is closed and the current in the circuit rises to a constant value of 1.70 amps. Calculate the energy stored in the inductor when the current has risen to its maximum value. You have a formula, E equals half Li squared. L is the inductance value, which we have from there. I is the maximum current constant value of 1.70. Plug the numbers in, there you go. B, calculate the value of R shown on the diagram and explain its effect on the maximum current. Well, we have the voltage across it. When it's at the maximum current, you'll have no voltage drop across anything else in the circuit because there's no other resistance values. So we can just V equals I times R. We know I, we know V because I is that current given above and V is 120 volts. C, explain the effect, and explain its effect on the maximum current. Nearly missed part of the, so the larger the resistance, the lower the maximum current will be. That's kind of the obvious statement. C, explain the effect of inductance on the time it takes for the current to rise to its maximum value. Okay, so this is explaining the inductance on the time it takes. So the larger the inductance, the longer the time it will take to rise to its maximum value. And I guess this goes back to the whole purpose. So you can look at time constant equation, all of that kind of stuff as well. But the idea of something with a high inductance means it has a high reactance to the change in what's going on in the circuit, so it will have a larger opposition to change. So inductance is, if it's larger, there's a larger opposition to change. There's our triangle, change to the change in current if we're being really specific, or the change in flux which is produced by that change in current. Okay, I'm going to leave that one. If you want to know more about that, email me. We'll leave that to there. D, switch 2 is closed in addition to switch 1. Explain what happens to the voltage across the inductor. We better zip back up to the diagram here and have a look. So there's switch 2. Now it's been closed after switch 1 was already closed. Switch 2, when you close it, absolutely nothing's going to happen because you've still got that gap where AB is, and it continues to act like an open switch in that parallel branch of the circuit. So nothing's going to happen. Moving on. So nothing, because AB is still a gap. Anyway, carrying on. Switch 1 is open, leaving switch 2 closed. Explain why a spark could be produced across the gap. And this is kind of the culmination of all of this, where the spark comes from. Once switch 1 is opened, the inductor, you've got that inductor internal resistance, and then the switch has been closed here, and you've got that gap between A and B. Previously there was a current flow through the inductor, which as soon as you switch, open that switch up there, is going to try and collapse, so the current is going to try and drop. Remember, the inductor opposes the change in current, so the inductor is going to induce a voltage to try and maintain that current flow. Okay, so a spark could be produced across the gap if the inductance values and resistance values are correct. That allows a high enough voltage to be produced to drive a spark across there, across the AB. That's pretty much the heart of it. You can get into really technical detail about the rate of change of flux and Faraday's law, and whether induced EMF is the change in flux over the change in time. and that's where it all comes from, that induced EMF. That'll be across from the inductor, which will drive across with a small voltage drop across the resistor to produce that spark. You can say you need a high change in flux or a very small change in time, and then when you're dealing with the voltage that you need across the gap here to produce that spark, you're having to explain that that internal resistance of the inductor and of the wiring and everything must be low enough for there to be a low voltage drop across there, so that there's enough of voltage over here again to produce that spark. There you go.